In this lesson, we're going to combine the ideas from solving polynomials with the ideas from linear inequalities to examine how we can solve a polynomial inequality. Again, an inequality means there's going to be a range of solutions. And just from a graphical idea, when we're talking about inequalities, and we have two different functions, we want to know where, for instance, one function is higher than the other function. So this was our example. We had fx being greater than gx. Where is fx above gx? Well, in the picture, the red line is above the blue line there, and also all of these spots. Okay, so if I can graph a polynomial, I can get an idea of the intersections or the different possible solutions. But we're going to learn how to solving these both algebraically and graphically. So to start, graphical solution. Rather than trying to graph these different inequalities separately and having multiple solutions, it's easier to go back to the idea of how did I solve something. Well, to do that, we always want to make it equal to 0. So what I'm going to try and do to solve a polynomial inequality is I want to make my function, a single function, equal to 0. Because then all I have to do is check if my line, my function, whatever it happens to look like, is above or below the axis. In other words, above or below 0. Okay, so for instance, look at this graph here. I'm going to solve this. I want to state my solution. I know where the function is above 0. Well, look at this graph. Here's where I'm at 0 in these three spots. So I'm above 0 over here, and I'm above 0 right there. So what would I say? I would say I'm above 0 when x is less than -3, and from 0 up to 1, 2, 3. And that would be my inequality notation, or sorry, my interval notation. Or from -infinity to -3, comma, 0 to 3. I'm using round brackets because I have a greater than sign in my question. I don't want to know when I'm at 0, I want to know when I'm above 0. Similarly, I can figure out when my function is below 0, like this one over here is below 0 in this section of the graph, and from here over. So when am I less than 0? Well, I'm less than 0 from 1, 2, 3 again to 0, and from 3 to infinity, or bracket interval notation from -3 to 0, and when I'm greater than 3. Okay, so it's actually pretty easy to tell am I above the axis or below the axis by looking at a picture. If I can draw that function out. That's going to be our key there, right? Drawing that function out. Some functions we know are actually pretty hard to draw. They have lots of parts and pieces, so it might be easier sometimes to create an algebraic solution. For an inequality, an algebraic solution, again, we want to figure out where it's going to be greater than or less than 0. To do this, you first have to find the zeros. We're going to call those things the critical values. In other words, where I'm above or below. Those are my change of my solution, right? And our new thing for today is we're going to create an interval using our factors to determine if the function is positive or negative. If I know it's positive, well, then I know I'm above 0. If it's negative, I'm below 0. How is that going to work? Well, let's take a look at this example here. Okay. I'm going to do this using an algebraic method, and then we'll show the graphical method just to prove the answer in the end. What are my zeros? My zeros are 3, 1, and -5. These are my critical values. This is where I hit the axis. I want to know where I am below the axis. So I'm going to make a table based on these critical values. And it works from the leftmost value to the rightmost value. The leftmost number is -5 on a number line. And then it's going to go from -5 to the next most number, which is 1. And then from 1 to 3. Oops, 3. And then greater than 3. And this is where my function is either below or above the axis in these intervals. because at these numbers, I'm on the axis. My factors of this, the parts that make up my function, is the number 3, the bracket x minus 3, the bracket x minus 1, and the bracket x plus 5. And if I multiply those all together, I get my function fx. Okay. This is my table. Critical values, which are my zeros across the top from left to right. And I talk about left in terms of the number line. And then my factors down the left-hand side. And what I'm going to do next is I'm going to figure out the sign of my function in each of these intervals. How I do that is I pick a number inside this interval. For instance, a number less than 5 would be -6. If I were to put -6 in for x, what kind of value do I get? Well, I can't really put -6 in for x. There is no x here. 3 is 3, and it's always a positive 3. But if I pick -6 and I put it in here, 6 minus 3 is -9. I have a negative number. -6 minus 1 is -7, a negative number. And -6 plus 5 is a negative number. And if I were to multiply all these things together, a positive times a negative times a negative times a negative, I end up with a negative answer. In other words, the function is below the axis. It's a negative in the interval x being less than -5. Let's try the next one. Let's pick a number in this interval. This number is 0. I can't put a number in for x, so there's no x. But if I put 0 in here, I get negative. 0 in that one, I get negative. 0 in that one, I get positive. Multiply it all together, I get a positive. I'll try the next one. Let's pick x is 2. 3 is still 3. 2 minus 3 is a negative. 2 minus 1 is a positive. 2 plus 5 is a positive. Comes out to a negative. And let's try x is 4. We get a positive, of course. A positive, positive, a positive. They're all positive, which makes a positive. So I have just proven that the function is less than 0. That's what the question was, right? Less than 0 when, well, when's it less than 0 in this interval, which was x is less than -5, and this okay, without having to look at a picture. Didn't need a picture. All based on my factors and my critical values. But let's say I wanted a picture just because I'm not so sure of what's going on here. What could I get from a picture? What do I know? Well, I know that I still know my zeros. My zeros are my zeros, right? I've got 1 at 3. I've got 1 at 1. I've got 1 at -5. That hasn't changed. I know my leading coefficient is a 3, which is a positive. I know it's got 1, 2, 3 axes, which is an odd number, so it's going down. And I know I have no special zeros. They're all regular pass-through zeros. So my shape is something like this. Where is my function below the axis? Well, it's below the axis in this section. In other words, from -infinity to -5. And it's below the axis in this section, which I hope you will agree are the same answers that we do with our table. Okay. Why would I use the table over the graph? Well, some things aren't easy to draw. They don't fit nicely on a graph. Okay. If I had a graph, I can use that just as well. I'm going to get you guys to try one. We're going to algebraically solve this, and we'll graph and check our solution, okay? So, what are my zeros? I got 0, and I got -2. My leftmost one is -2. I gotta go to 0. That'll be bigger than 0. And what are my factors that actually make up my expression? A -x, and x plus 2, another x plus 2, and then the function. All right, let's pick a number less than -2. Let's try -3. The negative of -3 is a positive. -3 plus 2 is negative, positive. Let's pick a number between -2 and 0, like -1. That's a positive, positive, positive. Okay, and then something greater than 0. Let's try number 1, a negative, a positive, a negative. Okay, what can I say? I can say that my function is greater than or equal to 0 when, what am I looking for here? Positives this time. So what would I say? I'd say x is less than negative 2 and from negative 2 to 0. Or if you want to use bracket notation, negative infinity to negative 2 and negative 2 to 0. I'm going to put square brackets on these ones, right? Because we have equal signs this time. Now, notice that at negative 2, it's included in both intervals. You could actually shortcut this if you wanted to. You could say negative infinity to 0. Because at 2, it is a 0, but that's allowed in this case because we have an equal sign. Okay, let's prove it with our graph. What do we know from our graph real quick? A 0 at 0, another one at negative 2. It's going to go down to the right. It's a cubic. There's 3 x's. There's a squared and a regular x. So up to the left, I've got a touching 0 at negative 2, a bounce. Looks like that. Where is this function above or equal to 0? All of that and all of that, which matches our math. Okay. Okay, let's try C. C is messy. C's got 2 different functions going on at once here. But we know that to make it easier, we can rearrange this function. We want to rearrange it so it equals 0 instead of having to worry about all the parts and pieces. Let's move all this stuff this way, okay? So we'll have 2x cubes minus 2x squareds minus 3x's is less than or equal to, less than or equal to 0. So move it over, collect your like terms. And what do I notice about all these things? They're all divisible by x. It's a common factor. Let's take that out to make our life a little bit easier. Okay. No, that's not 2x cubed, is it? It's just an x cubed. Sorry, guys. X cubed. Take it out. There we go. Okay. Let's factor this thing. This looks like a trinomial. Can apply man. Negative 3, negative 2, and negative 3 and 1. So I get x minus 3, x plus 1. There we go. Okay, what are our zeros? 0, 3, and negative 1. Okay, table time. From left to right. Less than negative 1. Negative 1 to 0. I have equal signs in this question, right? Because there's equal sign in the question. 0 to 3. And then greater than 3. I don't need that line over there. Okay, factors, parts, and pieces that make up the question. There is an x. There's an x minus 3. There's an x plus 1. There's my function. Okay, something less than negative 1. Negative 2 would work. Negative 2. Negative 2. And negative 2 plus 1 is still negative. 3 negatives make a negative. Negative 1 to 0. So you have to use a decimal here. Negative 0.5. Negative, negative, and a positive. And that makes a positive. 0 to 1. Let's pick number 1. Oops. I got 1 negative there. I need a negative. And bigger than 3. Number 4 will work. They're all positives. Okay, what was I looking for? I want it to be less than or equal to 0. That is true when, let's use bracket notation this time, negatives, negatives. I need that and that. So in 2 spots it's true. And if I had to graph this, how could I graph this? What do I know? Okay, based on my graph, I've got zeros at 0, 3, -1, up to the right, it's cubic, so down to the left, no special zeros. I want to be less than 0. Where is that true? Well, less than 0 is over here and in this section. Does that match my math? Below -1, yep, and 0 to 3, perfect. Now when we say f at x is less than 0, that really wasn't the question, was it? F at x was our change to the question. So what does this really mean? Well, it means I want to know when this stuff is true. Just move it down so we can see it. So our real answer is 3x cubed minus 3x squared minus 2x. That function is below this function when this is true. But we adapted that to make a single function to make it easier to solve. Okay. I'm going to try one more application and we're done. Word problem. Elevation of a hiking trail is modeled by this function, where h is the height above sea level and x is the position from a ranger station. A negative x value represents the position to the west of the station. Okay, so just things left and right, basically. Determine the sections that are above sea level. Well, above sea level would mean a height greater than or equal to 0. Right? 0 is sea level. So in our case, we have 2x cubed, 3x squared, 17x plus 12. Oh, we need to solve that. To solve that, I got to be able to factor it. This is where solving polynomials comes in handy. I'm going to have to use synthetic division on here. 1 and 12, 2 and 6, 3 and 4. Let's try one of those. F at 1 looks kind of nice. I guess it's h at 1 in this case. Comes up to 0. 2, 3, -17, 12, 1. Okay, what do we got? We know right off the bat, x minus 1, 2x squared plus 5x minus 12. And we want to be greater than sea level, and there we go, there's sea level. Okay, a trinomial, complex trinomial. Are there any numbers that multiply -24 and add to 5? Sure there is. 8 and -3. So we're going to keep on factoring this. Go a little bit further, I'll split it in half. Make sure we're on the right track with our brackets, and we are. And now we have ourselves a polynomial inequality which we can solve. There are zeros. 1, -4, and 3 halves, or 1.5. All right, leftmost. Less than -4, -4 to 1, 1 to 1.5, or 3 halves, and greater than 1.5. Our function, we may have some parts and pieces. What are our parts and pieces? X minus 1, x plus 4, 2x minus 3, function. All right, let's pick a number less than 4, -5, negative, ooh, definitely negative. 3 negatives make a negative. -4 to 1, the number 0 is a good choice usually. 1 to 1.5, well, I don't know, 1.1. That's a positive. 1.1 is still a positive. That's a negative. And number 2 would work. Positive, 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 positive. Okay, when are we above sea level? When is h at x greater than or equal to 0? Well, our intervals, the positive ones, are -4 to 1 and 1.5 to infinity. Okay, so how do I answer this word problem? It said in our question that a negative represents the position of the west of the station, so positive would be the east. So we could say we're above sea level from 4 kilometers west of the station to 1 kilometer east, and again everywhere more than 1.5 kilometers east of the station. And there's some polynomial inequalities. So algebraic methods and graphical methods. We can do both. We usually do one as a check against the other. I want to be pretty good at the algebraic stuff because it can be used for other things down the road. But might as well check with your graphical things so you don't forget how to do that. Any questions to try tonight? If you're stuck, come see me.